Okay, good morning, everyone, again. Okay, so now we go on to chapter 8, and we'll begin with section 8.2, multiplying and dividing rational expressions. And I am going to separate this into three parts, so today we'll look at part 1. We've spent some time simplifying fractions, and then we've spent some time factoring, and so today we kind of put everything together. So your I can statement for 8.2 is I can simplify rational expressions. Okay, so the key word here is rational. Rational meaning ratio, and ratio meaning fractions. So we are simplifying fractions in section 8.2, but fractions that contain polynomial expressions. Okay, polynomial expressions, and I'll get into that in just a second. But before we actually get into simplifying rational expressions, just let me review with you, go over some preliminaries. What does it mean to simplify a fraction? There's a question, what does it mean to simplify a fraction? Well, the answer, and you've probably never thought of it like this, but it means that you want to cancel out the common prime factors. Anytime you simplify a fraction, that's what you're attempting to do. So let me explain. So let me give an example here. So let's say here I have the fraction 4 over 30. And I want to simplify that. Okay, so what we're really doing is we're canceling out, or we want to cancel out the common prime factors. Now, prime factors being 2, 3, 5, 7, 11, 13, and so on and so forth. Okay, common prime factors. So it will be helpful then to express this fraction as its product of common prime factors or prime factors. So 4 prime factors of 4 are 2 and 2, so 2 times 2. And then prime factors of 30, let's see, here's 2 times 3 times 5. 6 times 5 gives me 30. Okay, so I've expressed that fraction 4 over 30 as a product of its prime factors. Okay, so what we're really doing when we simplify a fraction, we're canceling out the common prime factors. We say 2 goes into 2 once and 2 goes into 2 once. Okay, and now there's no more prime factors to cancel out. And so here this would be just equal to 2 over 15. Okay, but most of you would know that if you had 4 divided by 30 and you would divide both the numerator and denominator by 2, and that would give you 2 over 15. But what you're really doing when you simplify a fraction, you are canceling out the common prime factors. That's what you're doing. You're canceling out the common prime factors. Okay, and so that's what we'll be doing when we simplify rational expressions. Okay, we're going to be canceling out the common prime factors. Which is why it's important to know how to factor, because when we work with polynomials, you need to know how to factor and what does it mean to find a factor of a polynomial. So let me explain. So let me say here I have 4x squared, a polynomial 4x squared plus 2x. And so I would ask a question, and then what are the prime factors of 4x squared plus 2x? Well, we would know how to factor this, the greatest monomial factor. Let's see here, 2 goes into 4 and 2 goes into 2. And then for x squared and x, the variable is always the variable with the smallest exponent. And so that would just be x. So this would be an x and x. And so this would factor 2x. And then what's left over, 4 divided by 2 is 2. And then x squared divided by x is x. And then plus, and then 2 divided by 2 is 1, and x divided by x is 1, and so that would be 1. So my prime factors of 4x squared, we started with just this here, 4x squared plus 2x. My prime factors are 2x times 2x plus 1. Okay? So when we reduce or we simplify rational expressions, we have to write these polynomials as a product of its prime factors. Now, a common mistake students will do, okay, so 2x we would say is a factor. And then 2x plus 1 is a factor. So those are the factors then. So those are the factors of 4x squared plus 2x. But many students, and it's a common mistake, will say, hey, 2x is a factor, and so is this 2x, and okay, a factor, and so is that 1, and that will be incorrect because factors are not separated by plus or minuses. Factors are separated by multiplication. Okay, remember, factors are separated by multiplication. If you don't believe me, look up here. Okay, factors of 4 were 2 times 2, and factors of 30 were 2 times 3 times 5. Factors are always separated by multiplication, not by addition or subtraction. Very, very important. All right, and then likewise, let's say here if I wanted to factor this, I had x squared minus x minus 6. And so again, we'd have to find a common prime, or we have to find the prime factors. And so factors of negative 6 that add up to negative 1, and that would be a negative 3 and a positive 2. So FOIL, and you get x squared minus x minus 6. So again, x minus 3 would be a factor and x plus 2 would be a factor, but it would be incorrect to say that x is a factor and negative 3 is a factor and x is a factor and a positive 2 is a factor. That would be wrong to say that because, again, factors are separated by times, not by minus and plus. So x minus 3 is a factor and x plus 2. Very important. All right, so here, let's go over some examples here. I'll give you guys six examples, and then you'll have some work to do. Okay, so here, example number 1. Let's say here I have this rational expression. It's a ratio of 2 polynomials. 8x to the 5th divided by 2x to the 3rd. And I want to simplify that. So I can write both the numerator and denominator as a product of factors, and I'll be looking for the common prime factor. So, okay, so here I see I have a 2 in my denominator there, so a common prime factor for 8 is 2, and I can write 8 as 2 times 4. And then I see I have the smallest exponent I have for the variable is 3, so x to the 3rd is going to be a factor of x to the 5th, so I can write that x to the 3rd times x to the 2nd. Remember, when you multiply powers, you add the exponents. 3 plus 2 is 5. And then now I have 2 over x to the 3rd. Okay, so again, I could just as well express 4 as 2 times 2 because that would be 2 would be a prime factor of 4, and so as well as the other 2. But I'll leave it like that because I know that I'll just be reducing the prime factor 2. All right, so here we go. So 2 goes into 2 once and into 2 once. And then x raised to the 3rd goes into x to the 3rd once, and then x to the 3rd goes into x to the 3rd once. All right, so what I have when I'm done simplifying or canceling out my common prime factors, I have 1 times 4 times 1 times x squared, which is just 4x squared, over 1. Okay. Or it's just equal to 4x squared. Now, the thing we have to keep in mind when we simplify rational expressions, we always begin from where we started. And, okay, so this answer here, my final answer, 4x squared, will be true for where I started for all values of x except the value of x that makes the denominator 0 before I simplify. Okay, so you always have to start at the beginning to find the restriction. Okay, so here a value of x that I see I can't have in my denominator there, 2x to the 3rd. I can't have x is equal to 0. Otherwise, I'll get 2 times 0, and I'll have 0 in the denominator, and you can't divide by 0. So my final answer here will be yes, when I simplify as 4x squared, but then I'd have to state the domain restriction, x not equal to 0. And again, notice that in my final answer, I don't have a denominator other than 1. Okay, but that doesn't matter. You always go back from where you started. Okay, you always go back from where you started. Okay, the next example here, so example 2. So let's say here I have 5 x raised to the 6 over 10x minus 5. And I want to simplify that. Okay, so here again, I see there's nothing I can simplify in the numerator. That's just 5x to the 6. But in the denominator, I can factor out a 5, and so this will be 5 times 2x minus 1. 5 times 2x is 10x, and 5 times negative 1 is negative 5. All right. Now, let's take a look to see. So 5 is a factor, and x to the 6 is factors in my numerator, and then 5 is a factor in the denominator, and 2x minus 1 is a factor in my denominator. So what can I cancel out? I can cancel out the 5's. Okay, so then my answer here, there's nothing else to cancel out. Remember, again, this is a factor. 2x minus 1 is a factor. Some students would be tempted to cancel this x here with the x up there, and that would be oh so wrong. It would be oh so wrong because 2x is not a factor, or x is not a factor in 2x minus 1. 2x minus 1 is a factor. Okay, you can only cancel out common factors. So here, my final answer is x raised to 6 over 2x minus 1. Okay, so what would be my domain restriction? Well, okay, I can see from here or there that my domain restriction would be the 0 of the denominator, or 2x minus 1 equals 0, x equals 1/2. Okay, so I cannot have x not equal to 1/2. Otherwise, I'd get 0 in the denominator. Or if I go back to the beginning, 10 times 1/2 minus 5 is 5 minus 5 equals 0. Okay. So my final answer, x raised to the 6 over 2x minus 1 with the restriction x not equal to 1/2. Another example, example 3 here. So let's say here I have 16x to the 11th over 8x squared. All right, so what can I cancel out here? So I see right away, and again, I'm going to be a little lazy here. I'm not going to list all the prime factors of 16 and 8 because I see exactly where I'm going here. But here, I'll leave the 16, and then I see an x squared in my denominator, so I'll write my numerator as x squared times x to the 9th. 2 plus 9 is 11 over 8x squared. Okay, now I see what I can cancel out. So 8 goes into 8 once, into 16 twice. X squared goes into x squared once, and into x squared goes into x squared once. And so what do I have left over? I have 2 times 1 times x to the 9th. So this is going to be 2x to the 9th over 1, or that's just equal to 2 times x to the 9th. And again, my domain restriction is from where I started, so I see that I can't have 0 for x. So my domain restriction then is x not equal to 0. Next example, example number 4. So let's say here I have x minus 4 over x squared minus 9x plus 20. Okay, so factors of a positive 20 that add up to negative 9, that would be x minus 4, and then times x minus 5. Now, x minus 4 is a factor in my numerator, and x minus 4 is a factor in my denominator. I guess I could put parentheses around that if I wanted to. So, but x minus 4 and the x minus 4 can cancel out. And here I'm just left with 1 over x raised to minus 5, or 1 over x minus 5. 1 over x minus 5. But my domain restriction, again, is from where I started. I started here, or it's the same as that. So I see that x cannot equal 4 or 5. Otherwise, I'd have 0 in the denominator. If x is 4, I get 4 minus 4 times 4 minus 5, or 0 times negative 1 equals 0. And if I substitute in 5, you can do the math, but I'd get 0 again. It'd be 5 minus 1. 5 minus 4 would be 1, so 5 minus 4 would be 1. But then 5 minus 5 would be 0. So I'd have 1 times 0 equals 0. So x cannot equal 4 or 5. Okay, example number 5 here. So let's say here I have x squared minus 9 over x squared minus x minus 12. So again, factoring is the name of the game here. Okay, I have to cancel out my common factors. So x squared minus 9 I can factor as x minus 3 times x plus 3. And then x squared minus x minus 12 factors of negative 12 that add up to negative 1 or negative 4 and positive 3. So this would be x minus 4 times x plus 3. Now my common factors for both my numerator and denominator would be the x plus 3. So x plus 3 goes into x plus 3 once, and x plus 3 goes into x plus 3 once. There's nothing else to cancel out. I have x minus 3 over x minus 4. But my domain restriction, again, always starts from the beginning, or here. And so here, x cannot equal 4 or negative 3. Okay? And then finally, the last example I have here. So example number 6. So I have 2x minus 4 over x squared minus 2x. Okay, factoring is the name of the game. Gotta have to find those common factors for me to be able to reduce what's common. So from the numerator, I can factor out a 2. So this would be 2 times x minus 2. Over, and then from the denominator, I could factor out an x. So this would be x times x minus 2. So what factors do I have common? The only factors I have common are the x minus 2. So x minus 2 goes into x minus 2 once, and x minus 2 goes into x minus 2 once. And here I'm just left with 2 over x. But what's the domain restriction? Again, the domain restriction is, always starts from the beginning here. So here I see that x cannot equal 0 or 2. Otherwise, I'd get 0 in the denominator. Okay, so just to recall, so we're factoring or we're reducing rational expressions. Rational expressions are a ratio of polynomials, and so it's important to be able to factor because you want to reduce the common prime factors for the polynomial. Okay, so I've given you 10 problems to do. Look in this in this assignment, there's a PDF file with the 10 problems you're supposed to do, so complete those 10 problems and as before, submit it.